I'll put the recording on. Yesterday's class, I kind of went on longer than usual, so I'll try really hard not to do that today. So you have time to work on your assignment during class. That's important to me, especially in the summer. And if anyone has words of encouragement, just put them in the chat or tell us. Today is the 29th, day 3. We'll do sections 1-4 and 1-5. So like normally this would be our 3rd week of classes, right? We have a quiz tomorrow over chapter 1. And excuse me. It just goes right along in the summer. Okay, I see a couple of encouraging words there. Thank you, Hannah, Eileen. Almost forgot to give people their extra credit. Thank you both. And let me check who all's here on time. We just get your early extra credit because I wasn't early today. So I'll still give you extra credit, whoever got here already. Carrie, Deanna, Eileen, Hannah, Shanda, and Tommy. 6. 1, 2, 3, 4, 5, 6. Okay. All right, good. Does anyone else have words of encouragement or anything they want to talk about before we jump in? I really like this quote about the camera. I keep thinking of more things you could say, like it just kind of depends on what angle you're looking from and what you anyway, I just started thinking, oh, there's all kinds of camera analogies. Nice. Might be one of my new favorites. Okay, and so also announcements, and I'll say this again at the end. In WebAssign, you have to use your textbook voucher money to pay for the WebAssign, not your own personal money. It should have come from OLC. So if anybody is still using the free trial or they don't know how to get that to work or their voucher expired, just talk to me today at the end of class or at the break, okay? I'll get you fixed up. Okay, so far I have, I think 6, I just looked at it now. 6 or 7 students are doing their work in WebAssign. So I have a few that are not yet. So I want to make sure I'm not leaving anyone behind. Oh, Tressa's here too. I'll give you a point also, Tressa. Great, welcome. What we left off with yesterday was adding and subtracting fractions with different denominators and reducing fractions, changing mixed numbers to improper fractions and vice versa. And so we could just pick up from there. We have some topics to go through. Maybe I'll write them right here. So we're going to do adding and subtracting fractions and mixed numbers, fractions of all sorts. So we got to do a little bit more of that. Also adding, subtracting, multiplying, and dividing decimals. Usually that's easier for most people, but there are always some people that struggled with that. And I'll explain why, what happens with decimals. We also have to do multiply and divide fractions. And we'll talk about dividing by 0 or dividing 0 by something. And certain words like reciprocal, multiplicative inverse, additive inverse. These are just words that call out the different things that we're working with. And I like to use them so everybody knows them pretty well. And prime factorization. Sounds exciting, huh? So we'll do that. And like I said, I'm not going to go over time today with the talking. So if I have time, I'll talk about section 1.5, which is order of operations. Order of operations and exponents and using parentheses, or they're really called symbols of grouping, because there's other kinds of parentheses, like they could be like this, or sometimes they're square, and sometimes they're like this. So the big topic is symbols of grouping. And some of the things look really easy in section 1.5, but they're like subtle. So they look simple, but sometimes they'll trip people up because they're just subtle, weird, little quirky little rules. So we'll talk about that. That's it. That was my full plan for today. But like I said, if it gets to be like 2:15 and I still haven't gotten to this section, I'll just wait till tomorrow, because your homework is from this section and the one that we did yesterday, 1.3. That's what your homework will be over. And also the quiz. And the quiz will be tomorrow during class time on WebAssign also. Sometimes I'll give a paper quiz maybe next week and just have everybody do it on paper and upload it to Moodle, just to switch it up so you're not just like locked into that WebAssign. Is everybody okay? Ready for some math now? Got your math hat on? Good. All right. Super. The first year of the pandemic, I was just trying to make the Zoom class fun, and we had favorite hat day. We had wear a Halloween costume day, but it's really just your head and your face and head mostly. I should find my picture of what I did that year. I was trying really hard, but maybe we should have favorite hat day too on Friday. We could do something. Okay. Anyway, wasting time, huh? Let's see. Let's go to adding and subtracting just a little bit more. So for example, we left off and didn't do any like this. Couple of mixed numbers with different denominators. And how about 8 1/4 minus 2 and 3/8. And I was staying all in the positive yesterday with fractions, but we could go to negatives too. We could have -6 1/2, and no, a half, I already did a half. -6 1/3 minus -2 4/5. Ooh, and see those, if you've ever done these before, which you probably have, those are like about the hardest that they get with fraction work when we aren't using technology, just doing them by hand, you know. So I'm going to do one page. I'll do each one of these on a separate page. So first 3 1/2 plus 4 2/3. And then there's two popular ways to do these, or three. There's really three popular ways. People don't like me to show all the different ways. So if you're thinking, if I don't show an example of the way that you learned it, just stop me and talk to me, or see if like I might just be skipping that because I don't want to confuse everybody with lots of different ways. But I would, for this one, I'm adding their mixed numbers. So go ahead and just add the whole parts straight away, because subtracting, we can't do that. But with adding, we can. And then I'm just going to make a bar here. So then we're just going to add the fraction part, but we need a common denominator. What's our common denominator going to be? Nice work. Already I got someone doing these. Yes. You might want to just call out what the common denominator is. Six. Thanks, Shanda. Yep. 6 is the common denominator, and 2 times 3 is 6. So 1 times 3 is 3. 3 times 2. Oh, it's okay, Tommy. 3 times 2 is 6. 2 times 2 is 4. Add the tops. 7 and 7, 6. This is top heavy. That equals 1 with the remainder of 1. So it's really, oops, let me get it up here. It was 7 plus 1 and 1/6. 8 and 1/6. Good job, people that just tossed that in right away before I finished. Awesome. And Valerie is here. Hooray. I'll have to sing the Valerie song to you. Just kidding, I won't. Maybe after the break, you can introduce yourself. We could go through one round of introductions. All right, anyone have a question about that one? Like I said, there's other ways to do these also. You could change it to top heavy fractions and work them that way. Some people prefer that. Let's see, the next one is going to be 8 and 1/4 minus 2 and 3/8. These are just our examples that I did, the 3 examples that I started with today. Now, sometimes, and this wouldn't really be wrong either. I've seen students do this over and over. College students at all ages might go. They might subtract this. I don't recommend it. I used to say, oh, that's wrong. It's not really wrong though. Like 8 minus 2 is 6. That's correct. But this is going to be 2/8, 3/8. 2 take away 3, it's going to go to a negative number. So that's -1/8. That's okay. So 6 plus -1/8, you have to finish. It's going to be 5 and 7/8. So it comes out a little bit awkward for a second, but it's not wrong. So if your first instinct is to just do the whole parts and do the fraction parts. It could work. It's not the way we usually teach it, but it should work just fine. Let me show the way we usually teach it with the borrowing and all that stuff. The common denominator is 8. And what we do is say, oh, 2 is too small to take away 3. So we grab one off of the 8, turn it into 7 8/8. And go from there. So that's one way we could do it. I don't love that way too much, the borrowing, but a lot of people do. I like to go one more way. So 8 times 4 plus 1, that's 33/4. And I need it over 8. And then this is 2 times 8 plus 3. 16 plus 3. Now I could subtract 66 minus 19 is 47/8. And then turn it into a mixed number. So that way, to me, feels the most secure, but it's just a personal choice. So if you'd rather do the borrowing, you can. If you'd rather do that little negative awkward step, you can too. 8 times 6 is 42. So it's going to be 6 5/8. All right. No, it's not. It's 5 5. My bad. I was thinking about one thing and doing another. 8 doesn't go into 6 times. 8 times 5 is 40. Remainder 7. Sorry about that. I was like, well, that's not the same as my answer was. There. So that was the second example. Does anyone have a question about that? Maybe I'll show the borrowing way a little bit clearer too, just in case anyone likes that way or start kind of remembering it, but I just rushed past that way. So same problem. Get a common denominator. Add 8/8. Add one whole here and take one away. So that's going to be 7 10/8 minus 2 3/8. So it's 5 7/8. So that's the borrowing way. I won't show all ways every time, but I did kind of just rush past that one a minute ago. Anybody have questions about those two? The last one was this one, -6 1/3 minus -2 4/5. This brings in some of that work that we did with the positives and negatives. So we start to almost feel like almost like we're multitasking. So don't let that bother you. That's part of the fun of school math or logical thinking and stuff. Just like mechanicking, if someone's fixing a vehicle, they have a lot on their mind at once. They're trying lots of different things at once, or thinking, well, it could be this and it might be this. And I'll check this, but I'll also be watching for this. You know what I mean? Like they're under the hood, and Neil's brothers were fixing our alternator. I think it was our alternator. They were fixing that, and but then they noticed that the wires in my car weren't wrapped, and like that. Like notice things as you're going along. That's just part of the game. So right here we could go, oh, okay, minus. I remember that's plus, so I could get that handled. And then I'm going to write them in that stacked way that I do, but you don't have to. So we have a minus, plus 2 4/5 equals, let's do just with the common denominators. 3 and 5, the first common denominator is 15. So here's that, and this is 12. Stop me or say so if anyone has a problem with that part. Does anyone have a question? So like I was saying before, I picked this one for an example because it's one of the trickiest ones because it has a positive, a negative, mixed numbers, and different denominators. So we're not going to do a ton of these. Everybody already learned it at some point in their life. We're just doing a refresher and then a quiz tomorrow, and then we move on. So don't be like, oh no, is this what it's going to be like? So like this one, I personally would change them into improper fractions. That's my personal choice. You can do how you want of any of those ways I was just talking about. But 6 times 15 is 90 plus 5. So we've got negative 95 over 15 plus 2 times 15 is 30 plus 12. For me, it's easier to see then. I know that if they have different signs, I'll subtract and take the sign of the larger sign-free number. So the larger one would be 95. So the answer is going to be negative, and subtract the tops. And we're good to go. And if you have a fraction calculator, I'm not against those either. They just, if you end up taking trig and calculus, you'll move beyond that because it gets so tricky that the calculator doesn't give us the right format. But now I could change this back to mixed number because, and you might have heard this before, but since you all are new with me, I'll just tell you, if someone gives you a problem with mixed numbers, they want the answer to be mixed numbers. As a kind of a rule of thumb, 15 times 3 is 45, remainder 8. There. Just like if I ask someone, where's the beach in Spanish? If they could answer me in Spanish, that's ideal, right? If they only could just point, that's okay. Like it's better than nothing, right? I'll still find it. But that's how it is in math. If they give you a question in fractions, answer in fractions. If they give it in decimals, get your answer in decimals. If they put it in words, do your answer in words, your ultimate answer, if you can. So that's just a good rule of thumb and easy way to remember, because otherwise people are like, well, can I put it in decimal? Do I have to do fraction? So that's just a good rule of thumb. Anybody have a question about this very strange, tricky one? Then we'd keep reducing if we could, that 8/15, but it doesn't go down any further. Remember that word from yesterday, relatively prime. 8 and 15 are relatively prime because there's no common number that divides into both, except 1. 1 does. Just checking who all is here now. Oh, great. Good. We got 9 of you here now. Hooray. All right, want to practice? Let's practice 2 of these. Then move on to multiplying and dividing. Much easier. So this is practice if you want to send me answers for extra credit. Let's do 1. There, I'll pause the recording. In fact, let's see, 45 minus 30 would be 15 plus 2 more. And then it doesn't reduce anymore. So that would, for that one, I think that's the fastest way to do it, that borrowing method. So if I took one whole off of that 9 and it went here, and that's allowed as long as we keep it balanced. We don't take anything from where we can't balance it out. So let me see. Hillary, Eileen, good job. Carrie, good job. Nice. Wow, what a group this is. Anyone have questions about that one? On your homework assignments, I usually give you 5 tries for each problem because that's one nice thing about working with computer software. Like, I'm not a huge fan. I'd rather see people's paperwork. But during the pandemic, we've just been using this method the most because sometimes I had great big classes and then people didn't have scanners and it was like a big cluster at first. But the nice thing about that computer homework is that you have more than one try at your answers. You could click on the watch this video or show me another problem like it or find it for me in the book or those kind of things. So you have some more resources than you do if you're just working out of a regular old textbook. So remember that when you're doing your assignment, it's not just one and done, like we say in karate. It's not one and done. You have, I think, 5 tries, most of my homeworks. And on your quizzes, there's 2 or 3 tries for each. Okay, I'm going to refresh my whiteboard because now let's do multiplying and dividing. Fractions. We won't spend as much time on this because it's not as tricky of a concept. Multiply. So when you're multiplying fractions, you could just multiply straight across. And then reduce if necessary, but that one doesn't reduce. So always you're allowed to just multiply straight across and reduce. Sometimes they're a little bit more fun, like let's say 8/9 times 12/20. Then you can cross cancel. So the number that goes into 8 and 20, who knows what could divide into both of those? So that's the word cross cancel. Not cross multiply, but cross cancel. Yep. 4 goes into both of those. So I can break those down to turn them into 2 and 5. And do the same here. 3 goes into both of them. And then multiply straight across. Well, that's really weird that they both have the same answer. I just picked that one out of the air too. Oh, strange. But anyway, that's that. Cross canceling is pretty fun. If we have mixed numbers, and we'll give some practice with this too. Mixed numbers like 3 1/4 times 5 and 2/3. Then there's some tricks where you can do the FOIL method with this. And we're supposed to teach that to the elementary teachers, but we usually just turn them into impropers and cross cancel. If there's anything to cancel, this one has nothing. So I just have to multiply 13 times 17. And then divide the bottom into the top. let's see, that would be 5, 6, maybe 9. Let's see, what's 12 times 9? Oh, much more than that, right? Let's just go this way. 12 into 22 goes once. And 12 times 8 is 96. So it's going to be 18, the remainder here, and that bottom number stays. And if I'm going to always be encouraging you to guesstimate, like estimate what your answer is going to be, and always have an idea in your head. So like I know 3 times 5 is 15. And with fraction parts added on, it's going to be closer to a little bit more than 3 times 6. So that answer of 18, just under 18 and a half, makes a lot of sense. Otherwise, if we don't have a little handle on what we're expecting, we just feel like we're thrashing around lost in a storm kind of sometimes. Does anyone have a question about that one? Let's talk about division too before we practice these ones. Fraction division, we take the reciprocal of the second fraction, so we flip it. And then multiply. So for fraction division, and then multiply like normal. So let's say, how many how many 1/4 are in 15/16? That's what that means. 15/16 divided by 1/4. Take 15/16 times the reciprocal of 1/4. Cross cancel if you want. That's going to be 3, remainder 3, right? Yep. 3 3/4. So when we're dividing, that's what we're thinking. How many of these would fit into that? Just like regular old division. Wow, I'm really proud of everybody doing that good work. Wow, wait. All right. Let's do one with a mixed number with division. Let's say I was saying, okay, I've got 10.5 candy bars. Everybody's going to get, I'm dividing by a quarter again. Everybody's going to get a quarter candy bar. How many people will be fed? So that's what that means. But don't worry too much about all that. We just can follow the algorithm. And the algorithm is just the method, like the recipe for solving a problem. So I would take my mixed number and change it to an improper fraction. Multiply, reciprocal. Pause it and you could tell me the answer. This will come out a whole number answer because I set it up on purpose because I was talking about people getting fed. We don't want any fraction of a person. Yeah, good, Valerie. Yep, excuse me. I just have such a runny nose today. I think it's my allergies. Too much running around outside. Good, Tressa. Great. How wonderful. And watch, if I forget to cross cancel, I would have 40, not 40. I'd have 84 just if I didn't think of cross canceling or no one ever taught me. And then I could still divide 2 into that, still get the right answer. See? So it's not that important. Like when I was a student, we didn't learn cross canceling. We just did. They just didn't teach us. I don't know. I don't know if they knew back then, way back in the dark ages. Great. Oh man, that's so good. Good job. Tressa, Carrie, Tommy, Valerie. Sweet. Okay. All right, now we better do some practice ones, then we'll go over them. We'll do prime factorization and take a break. So let's practice more. Practice these. Oh, I didn't talk about using a whole number either. I will. Remember, a whole number you could always write as a fraction with 1 underneath it, but I'll show that too. So here's 2 multiplications and 2 divisions. There, I'll pause this and
I just had to catch up on all of those. Hopefully, I guess I better ask for a thumbs up. I put on my headset. Can you guys still hear me? Or no? Yes? Good.
I can still hear you.
All right, thank you. It was getting noisy in my background, so I thought I better do that. Or I was getting distracted my own self. That one's 1/16. This one is 3/8. Now this if you ever are teaching or working with someone who first learned their fractions with you, they'll be like, no way, because multiplication, we thought it made things bigger. It always made things bigger before, like 5 times 4 gets bigger to 20, right? Yeah, so it feels weird, like how could that be true? But we're just taking a little 1/4 piece. If you've ever used fraction bars at school, it's a lot like those base 10 blocks. It can help. But anyway, this next one is 9/4. I know this isn't a class just for people who are going to be teachers, but I like to mention those things because a lot of everybody I know anyway, either has some children around or a friend or somebody once in a while, it's going to be like, why? Why is that? Why are you doing that? Why are you telling me to do this and that? So anyway, those are the answers for those 4. Good job. Does anyone have a question? Good explanation too, Eileen. Thank you. Yep. Oh, and Carrie, I give you your points. And Eileen, I mean, 1, 2, 3. Carrie. 1, 2. I'll call on people for this next one before the break, okay? So you don't feel like you're just having to be silent, boring silent day. Prime factorization. We're going to make a factor tree. Well, I'll show you one and then ask you to do a couple before the break. Factorization. So a prime number is only divisible by itself and 1. Like 2, 3, 5, 7, not 9 or 10, 11, 13. Those are our first prime numbers. 1 is not a prime number because it's like a unique, special, weird one because it's only divisible by itself, which is 1. So like the logic of that is why 1 doesn't get included. But anyway, those are prime numbers. So we take a number like 120, and that's not a prime number. We want to break it all the way down to its prime factors, it's called. So the factor tree, I might as well make it green. Somebody tell me, there's lots of ways you could, 2 numbers that multiply to make 120. Anybody want to take a shot at that?
10 and 12.
60.
Both of those were right. 60 and 2, is that what you said? 10 and 12, 6 and 20. Any of those would be right. So you could try whatever path you want. Let's say I did 10 and 12. All those were right though. Then those need to break down. 2 times 5, 2 times 6. Circle my prime numbers as I hit them. So those are done. One more on the 6th branch, the number 6 train. There. So the prime factors of 120 are 2 times 2 times 2 times 3 times 5. Just the ones that were circled. Or I could say 2 to the 3rd power times 3 times 5. So no matter what, those are the numbers that go into 120. No matter what order they're in, it wouldn't matter what order. But that's called prime factorization, or this way of doing it is a factor tree. You could have learned it like this too. I've seen it done like this, and they make like a little step. So let's say somebody did 6 and 20. And then what goes into 22 times 10? 2 times 5. Oh, but my 6 still has to be 2 times 3. So that would, I made it look kind of weird, but I've seen it done with those stair steps too. And then that's not to be confused with what I was saying yesterday, and people learn this also kind of at the same time in school. Like if they take 120, all the factors of 120 are 1 goes into it, 1 times 120, 2 times 60, 3 times 40, 4 times 30. Let's see if I run out of space. 5 times 24. 6 times 20. 7, 8 goes into it. Times 15. 9, no, 10 does. 10 times 12. And that's it. So these are all the factors of 120, but they're not all prime. So I know some people will be like, do it that way and then pick the prime numbers out of there. But some were repeats, remember? Let's go back. There's repeats of the 2s. So I personally think the factor tree is the best way to really get it all figured out. So you know, you're really breaking it down to see what it's made of. So it's kind of like smashing it like an agate, huh? You want to wreck it, but we'll just get it down to its prime factors. All right, so let's practice 2 before we take our break. And this is how they'll write it. Find the prime factorization of do 500 and 620. There, we'll pause this while you. So 2 isn't going to go into it. So go to the easiest number that you can find that goes into it. So I know 3 goes into it, and the way that I know this is the rule of 3 divisibility. Good, Valerie. Yep. Is if those 3 digits add up to something that is evenly divisible by 3, that tells me that this big number is divisible by 3 directly, because otherwise, even with the calculator in front of me, I could be lost. But 3 into 621 is going to be 207. Then the same thing happens. 2 plus 0 plus 7 is 9. 3 goes into 9. So that's going to go by 3 again. 69, isn't it? Now I've run out of room. Let's see if I turn it sideways. Sometimes it works. I'm going to turn it sideways and hopefully it's not all upside down for you. 621. I'm going to rewrite it so we can see it. Thank you. Yep. Three again, and then it's done. So it's 3 to the third times 23. Very nice. People sending in answers while I'm doing that. So I hope you can see that. Can anyone, is that cut off on anybody's screen? Or are you okay? You could circle them this way too. Here's our 4 factors for that number. And those are the prime factors that are circled. All right, let's take our break for 10 minutes and then I'll give you all credit who just sent me these answers. Good, Valerie. Yeah. Good job, everybody. Awesome class. So if you come back at 2:20, we're only going to do about 10, 15 minutes of decimals and call it a day. So that is the plan. I'll pause the recording. Hello, we're back. Okay. Give me some kind of a signal that you're here, please. Some of you have. Very nice. Thank you. I'll tell you, let's see, what am I feeling like today? There, a dragon. Oh, messaging is good too. That's all good. Sometimes I'll call everyone by name or ask everyone to turn on their camera. I don't think that's really a priority all the time. Whoa, but I love seeing you. Thanks. All right, so as promised, I'm just going to talk about a little bit more stuff and then save the rest for tomorrow. So we'll make sure that the recording's on. It is. Before we go any further, we've got to note that 0 divided by anything equals 0, except it can't divide by its own self, etc. So 0 divided by 0 is not, it has a special name. It's not, oh yeah, it's indeterminate. Let me write it here. So that's not allowed officially. Indeterminate. They won't ask you that. in our textbook. They won't put that on the assignments because there's a whole big gray area. It gets kind of into the calculus thinking and abstract stuff. So they call it indeterminate, because what confuses people is we know that anything, like anything divided by its own self equals 1, or if you write it on top of itself equals 1 whole. So we know that. So students sometimes logically, and it is logical, they logically go, well, then that should equal 1 also, but it doesn't, because 0 divided by anything equals 0. But 0 divided by 0 is nothing's going to work. So it could be, I could show you why. I will show you why briefly. Okay, the reasoning behind anything division is because you could multiply going backwards. So 0 times 7 equals 0. That's true. 0 times 8 equals 0. That's true. 1 times 9 equals 9. So you can always back check like that. Just like you could check your subtraction by adding back up, or check your addition by subtracting, but you don't usually have to do that. But look what would happen if I said, watch this. If I said 0 divided by 0 equals 17, don't write that down though, or don't memorize that one. Because look, I could use math and say, because 17 times 0 equals 0, check. But I also could say 0 divided by 0 equals 46, because anything times 0 equals 0. So then suddenly there's an infinite number of possibilities for that answer that would follow the logic. So following the logic, that would be true, but we can't go there because that would just confuse things totally. So we say indeterminate because you can't determine the answer. Indeterminate, can't determine it. 0 divided by 0. So that, or 0 divided by 0. No, not allowed. Exactly, Tommy. There you go. Yes, it does. Because look what happens. We say 7 divided by 0 is undefined. Or like this, you might have learned under the line, undefined. It doesn't equal anything. And the reason is the same thing. Like if I thought, let's say I was thinking about it, but this isn't the answer. If I was like, I think 7 divided by 0 should equal 7, because I did divide up my 7 candies and I still have them. I'm like, if I'm just thinking that, then I should be able to prove it by multiplying backwards. 7 times 0 does not equal 7. So no, that's not right. So that's how I could, always in math, we always can back up what we say with some rule or another. Sometimes they're weird rules and they back themselves into a corner, and this is a time when they did. So anything divided by 0 is undefined, but 0 divided by anything equals 0. 0 on top is okay. Because of that same reason, like I was just saying, you can multiply back. 0 times 5 equals 0. That's true. So I can check it and it comes out okay. So that is really hard for people to keep track of those two rules, like which is allowed. And so my students in South Carolina are the ones, they're like, didn't you learn 0 on top is 0, just stop. That's what they taught me. These are college students too. 0 on top is 0, just stop. Then they'd go, under the line, undefined. So if you haven't heard that before, that might help. I think it helps a lot of people because it's just hard to remember this checking back with multiplying backwards, but multiplying backwards always works. Like let's look at a regular division situation. 12 divided by 2 equals 6. The official reason why, actually, in mathematics is because 6 times 2 equals 12. That's actually the official mathematical reason why that division is true. So you can back it up to like regular numbers if it ever starts to get too weird and abstract. Which reminds me of one other thing too, along the same lines. If I'm saying 12 divided by 2, I don't usually do this. I mean, I do this, but we don't do this because it makes it harder for a second, but 12 divided by 2 is the same as saying 12 times the reciprocal of 2. See, that makes it be more work, right? But that's what's going on with that fraction rule when we take the reciprocal of the second number and multiply. Because I wasn't taught that. Why? Why do you change to multiply? Why do you flip the second number? Why can't you flip the first? All those kind of things. But division by a number is the same as multiplying by its reciprocal. That's another little like obscure math fact, how related. Division and multiplication are like kissing cousins that got a little bit close. They're kind of codependent even. So that's kind of interesting, but just a little side bit of information I wanted to mention before I went on. And then that moves us right along to this. The multiplicative inverse. I noticed that I asked this on the quiz, and I know I didn't teach it yet. The multiplicative inverse. That just means the reciprocal. And the additive, I'll explain why briefly. Additive inverse means the opposite, the same number, but the opposite sign. So what those are things that we use a lot in algebra without even really talking about it too much once we get rolling with it, you know. And so the multiplicative inverse, it undoes multiplication. It cancels out multiplication. So like if I had 1 times 5, and I wanted to undo that 5, then I just go take the multiplicative inverse, and I'd be back to 1. When you do that, you could put them over 1 if that's confusing. So the multiplicative inverse it undoes, it cancels out a multiplication. So here's when it happens a lot. Like if you have 8x equals 24, we're saying 8 times something equals 24. We can get that 8 away by taking 1/8 times each side. That's what we're really doing, taking the multiplicative inverse. We don't really talk about it. Like we'll say divide both sides by what's with x, x equals whatever. You can tell me what it equals if you want. But that's what we use, that multiplicative inverse a lot. And that was a great question, Tommy. I'm going to give you some extra credit for that because love those questions. Keep them coming, everybody, if you have still questions about it, because so many people were taught these rules by teachers who weren't that comfortable with them. And the teachers would say, it just is what it is. That's the answer. You just have to do it that way. That's what a lot of teachers will say. That's just because they're a little bit insecure or they were taught that way. But they didn't know. It's like, just like if you play poker, you play complicated poker, like Texas Hold'em or things like that, where there's just like, or baseball poker, lots of different rules, different little subtle pieces of it. Sometimes people don't even know and they're just playing without even thinking about explaining the rules. So then some people hate all the rules in math. I understand that too. But some people are just comforted by it. So the same with the additive inverse. If I have like a plus 3 equals 9, I know how to get a alone. I take, you probably all do too, I bet already. You take the opposite of 3, that goes to 0, and do it on the other side. And get a equals 6. People know what they're doing usually, but they might forget that it was this word. It's just the additive inverse means the number you add to something to zero it out. So I wanted to just mention those words today before we stopped. And then decimals. Oh, and this too. Just like I was just saying, a whole number equals that number over 1. A number over itself equals 1. But like 1/5, you can't say that that equals 5. That sign, that line through it means not equal to. You can't say that the other way around. It's not true. 1/5 is the reciprocal of 5, but you can't say they're equal. So there's just these little things too going into the chapter 2 when we start to do our algebra equations and stuff. We'll use all those. So briefly for decimals, and then I'm stopping. For adding and subtracting decimals by hand, we just mostly want to line them up. And sometimes people struggle with understanding where that would actually be located and stuff like that. And which one's bigger than the other. Like this one, because it has more digits, it looks like maybe it's bigger, but actually this one's bigger. So we do a little bit of that greater than and less than with decimals, but I don't stress it too much because it comes up later on anyway. But if we're adding by hand, this is why teachers are so picky about how you line it up. And like in Africa, they use graph paper or grid paper, in France too, for all their math work. And it's just like really OCD lined up, so careful. And I love seeing that, but I also love doing math problems where I'm writing all over a page or a book or a napkin. It looks like insanity sometimes. So I'm not always perfect with that, keeping it lined up. But when I'm teaching, I have to, obviously, because we just want to make sure nothing gets crowded into the wrong place. Because if someone learned how to add, this would be wrong, but I've seen people do this. They add it the way they learned to do with regular numbers, and the decimal points aren't lined up like they're supposed to be, and it'll come all messed up. So be careful with that, with adding and subtracting. We'll just practice a couple. And then with multiplying, it doesn't matter how you write the multiplication. Like 1.25 times 0.2. Like I can write those that way, but I'm just going to be really careful at the end. 2 times 2 plus 1, 2. And then I count from the right, 1, 2, 3 digits. 1, 2, 3. So it equals 0.250. And then with decimals also, I'm not teaching this today, this part, as if you've never seen it, because if I was, I'd be going too fast if someone was new to this. But there's just a lot of little things to refresh and remember. But this 0 right here, because it's on the end of a decimal, it doesn't have to be there. So 1.25 times 0.2 equals 0.25. And what that means in fraction language is 1 2500 times 2/10 equals 2500. Because if you're skeptical, which is a good thing, be skeptical, and sometimes I'll make a mistake and catch my mistake and get big extra credits because that means you're paying attention, right? But this is 1 1/4 times a fifth, so you can think about it in fraction terms, and sometimes it helps just to have it make a little bit more sense of what the answer is and how it's relevant to the original question. So just be careful with your multiplying, that you set your decimal point in the right spot at the end. And then I'm going to go through one division because of that one student that I had, like I told you all yesterday, who shall remain nameless, of course, always. But I felt terrible because I should pick up on that and know. I should either read body language or get someone to disclose to me if they need more help with something as a teacher. So it was a failing for me as a teacher that student struggled like that. So let's say if we had 75.425, divide it by 0.25. There, that's a pretty hardy one. That'll be good for the last example. Then we'll do a practice page and then stop for today. Then I'm going to stay logged on and meet with a couple people in breakout rooms, and you could either stay logged on or log off to work on your assignment. But today it's assignment chapter 1, assignment B. B as in Bebela is due tomorrow. And there'll be a quiz tomorrow too, but I'll talk about the quiz during class tomorrow before quiz time. If you've done all your assignments and been to all your classes, you'll do fine on the quiz. Okay, so make sure I copied it right. Move our decimal point off of the divisor. It went 2 spaces, so it's going to have to set right there. Then I'm really careful how I line things up. And 25 into 75 goes 3 times. Subtract. Bring these down. 25 doesn't go into 4 right here, but it goes into 42 once. And I can erase that arrow so it doesn't junk it up. Now this will be what, 17? And then 25, think of quarters, money going into $1.75. How many times does 25 go into 175? Anybody still with me? You are, I see you. Excellent. Way to finish strong today, huh? Yep, so that's the answer, 301. That one is what I was saying yesterday, a terminating decimal. I don't go too much into the repeating decimals and all the messy junk with decimals when we're doing our review days. So just that technique of how to do that. And of course, you could use a calculator if it's going to have a terminating decimal. You know, calculator could do that, double check for you. And then here too, remember, like I've been saying kind of over and over today, you could take your answer times that number and get that number. So you could do the opposite operation and go backwards to check. So the check, you always could do that whether you had a calculator or not. 301.7 times 0.25 is going to be 75.425 when you get that all finished. So that will definitely work. Okay, let's do anyone have a question before we do our practice page? Practice whiteboard screen. Okay, let's practice. Let's go. Which page that'll work for us? So let's practice. There. Those aren't too long and drawn out, so I'll pause the recording again. We can, or someone could take over the whiteboard and do it. Also, you're always welcome. If you have a touch screen that would do it, or you could mouse over it. I am not sure about the mouse. Okay, move this over one. Move it over one here. There. Now 2 into 7. 2 into 10. And 2 into 0. So that's why it's 350. That one, if anyone got that wrong, it would have just been a decimal placement issue. So you can verify with a calculator, or you can multiply that times that if you're not convinced. So don't ever just say something because your teacher told you. Just always make sure you give it some thought and see if you can make sense of it. That's the best way. Any questions about these? Does anyone want to see any of the 1, 2, or 3 done out? Good job being called on the spot. I wrote your initials down, so I'll try to call some other people next time when I do that stressful trick. All right, so assignment B is due tomorrow, quiz tomorrow. You can work ahead if you want. I'll be here logged in for another half hour or 40 minutes. If you have questions, I'm going to meet with a couple people in breakout rooms. But you don't have to stay logged on if you want to just do your assignment. But you can though. So if it feels better to be with everybody logged on, you can. That's awesome. So, but I won't get mad at it. Turn on your camera and wave goodbye if you're leaving, or give us some kind of signal. I should have like a hat toss or something on mine. Oh, I do have a hat, I think. There. Okay. All right. See you, Dawn. See you, everybody. And I'm just going to go get my other device and get back, put in the breakout rooms for whoever's left. Okay? Or you can jump back in. So it's all good. Have a good evening. Oh, yeah, that's fine, Tommy. Yep. Absolutely. See you, Tressa. Oh, she might be going already. Bye, Janda. Good work. Good work, everybody. All right, I'm stopping the